So the first thing to do here is to translate these relationships. So their sum is 900. R is a perfect square that's between 150 and 500. Maybe you can think in terms of extremes. It could be 169, which is 13 square, and then so on and so forth. And we'll go all the way up to 484, which is 22 square. So these are the set of values we have to consider. Now this other inequality is that P is greater than 0.3Q and less than 0.7Q. Now our interest is in P, so I will get rid of Q in this inequality. So I'll isolate Q here, which is 900 minus R minus P. So I have Q in terms of P. I'll substitute that here and then rewrite this inequality in terms of P. So I'll just do the first portion here. So it's 0.3 times 900 minus R. Distribute that 0.3P. So most of the work is at this stage. 1.3P is greater than 0.3900 minus R. So that's one relationship we have. And the reason I'm doing that is because my interest is in P. So just get rid of Q, which you can think as an intermediate variable. So we do the same thing here. P less than 0.7Q. 900 minus R minus P, and I'll keep these two together. Distribute and then move that 0.7P here. This is less than, so yeah, watch out for that. So that would give me P is less than 0.7, 900 minus R over 1.7. And if I bring that one here, this is the summary. Now we can proceed from this point onwards in terms of finding the least and the greatest value. So I'll start to find the least value. We'll try to make that as small as possible, and that means I need to make R as great as possible, so 84. So if I replace that with 84, sorry, not 84, 484, that would give me this inequality here. And I'll compute these values, but this is the part I'm interested in because that would give me the lower limit. 900 minus 484 times 0.3 divided by 1.3. So I get 96. And this one, let me just, I think if this was in the exam, I would be computing that as well. So that's less than 199.3. But this gives me the least value is 97. Now I look at the other extreme where R is 169. In that case, 900 minus R would be as large as possible. And this would give you the upper limit. So if I replace that here with 169, and I'll compute this 900 minus 169 times 0.7 divided by 1.7. I get 301 here. And this number, the other side of the inequality, this would be a small, and let me actually just do that so that you can kind of clearly see the answer. Times, actually I have to do the other way. So 169 times 0.3 divided by 1.3. So I get 168.7. So you can clearly see that the maximum possible value is going to be close to 300, one less 300. So that's our greatest possible value. That's the least. They're asking for the sum. So it's 397. I mean, it is a difficult question in the sense that if you didn't do this initial work of rewriting this inequality, I think it's a little bit more confusing in terms of plugging in numbers and then playing with these same relationships. It's just not as clear, in my opinion. So doing this, yes, there was more algebra here, but once you're here, it's easier to see what those values are by looking at the extremes here. So to summarize, the answer is 397.